We've looked at differentiating the trig. Let's now go back the other way, integrating it. Now, if I integrate cos, I must get sine, because you remember that when we differentiated sine, we got cos, so going back the other way. I've just gotten cos of a linear function in there. If it's a linear function, then out the front I'd have 1 over the coefficient of x. Think of it that way, so 1 on a. Sine, well, that'll end up being negative cosine, because when we differentiated cos, we got negative sine. Now this is where we've got to be careful, where the negative is, because when we differentiate cosine, we get negative sine, but it's when we integrate sine, we get the negative. It's very easy to get those the wrong way around. And the other one, sec squared, well, that must go to tan. But remember, you will have the reference sheet. If ever you think, hang on, which one goes to negative, make use of it. It's there to help you. All right, let's do some. The integral of sine 3x then. Well, 3x is a linear function, so it's not an issue. Sine goes to negative cos, so minus 1/3 cos 3x. Cos of 1 minus 5x, well, cos goes to sine. The coefficient of x in this case is negative. So we still do get a negative with this one. We get negative 1/5 sine, and the angle doesn't change. Let's do a sec squared one. So sec squared, x on 2, well, sec squared will go to tan. The reciprocal of a half is 2. A definite integral then. So sine 2x, sine goes to negative cos. So I'm going to have negative a half cos of 2x. Substitute in, and remember, radians. Whenever we're dealing with calculus and trig, it's radians. It has to be radians. Now, cos of pi minus cos pi on 3, and that ends up being 3/4. And you'll see these numbers come up a lot. So the pi on 3s, the pi on 6s, and pi, because those are our exact values. And we can substitute in whatever they happen to be. Root 3 on 2, 1 on root 2, all of those sorts of things. Now you'll notice this one's not a linear function, so how do we handle it? Well, we want to set it up so it looks like what we recognise to be derivative times sec squared in the angle. The derivative of x squared is 2x, so I'd like to see 2x out the front. So let's make it 2x, balance it out, I'll put a half out the front. It's now in that form we recognise. Derivative times sec squared of an angle, well, sec squared goes to tan. So that'll be a half of tan of x squared. So that's how we handle ones that aren't linear functions. Get it in that form, derivative times the trig of the function. As opposed to sine squared x, now the angle is linear, but it's sine squared, and we don't have like a chain rule for integration. So how am I going to handle this? Well, I'm going to handle it using trig identities. And if you recall back when we did double angles, I said these things will come in very useful next year. It's that time. And that is our double angle results. Remember, cos 2 theta is cos squared minus sine squared. We know that. Which I could rewrite as 1 minus 2 sine squared. And if I make sine squared the subject, I get a half of 1 minus cos 2 theta. And that's what I'm going to use to integrate the sine squared. The other one, of course, was the cos squared. We may as well look at that at this point as well, and that gets that cos squared is a half of 1 plus. So you see they're very similar, it's just one is minus cos 2 theta, one is plus cos 2 theta. So the cos squared has the plus, the sine squared has the minus. It's a very, very common question you will see, because they love checking to see, oh yes, do you know this double angle result? So integral of sine squared will change to a half of 1 minus cos 2x, and I now have two things we can integrate. The one, of course, goes to x, and the cos 2x, well, cos goes to sine 1 over 2 sine 2x. I've expanded it out, so I get x on 2 minus a quarter sine 2x. Well, we didn't integrate tan. We have one there for sine, cos, and sec squared, but what about tan? Well, in order to do tan, I rewrite it as sine x on cos x. It's now in the form of derivative on function. Well, almost of the form derivative on function. Because the derivative of cos x is minus sine x. So to balance it out, I'll put a minus out the front. It's in that form, I know it's a log function. So I get minus the log of cos. Now what I say to you is this, don't do that every single time. just remember the integral of tan x is minus the log of cos x. It's a standard integral, but it's not on the reference sheet, but that's okay. You can still use it. There's a lot of what I call the non-standard integrals. They're not on the sheet, and as we go through integration, I'll point them out to you. But I think it's a good idea just to remember them to save yourself some time. You don't have to derive it every single time. Now, of course, if they asked us the question, show it's this, well, all right, then we've got to do the working out and show where we got it from. There is another way of writing this, if you don't like the negatives, because negative log cos, with the log, I can bring the negative in. And it's like saying cos x to the power of -1, well, the reciprocal of cos is sec. So if you wanted to make it a positive thing, you'd say, oh, it's the log of sec plus a constant. They're equivalent answers. Cos x sine to the power of 7x. Got these two things together. But it is in the form of derivative times a function. If you don't see it straight away, let's do a substitution. Now, the substitution I'm going to do is u equals sine x, because what's causing me the problem? The problem is that power of 7. And sines to the power of 7, I'll let u equal what's causing me the problem. So u is going to be sine x. That means du is cos x. Differentiate sine, I get cos. Because it's a definite integral, I'm going to have to change those limits though. Because I'm going to make everything with respect to u here. And those limits are with respect to x. So we substitute in. When x equals 0, well, sine of 0 is 0. When x equals pi on 2, well, sine of pi on 2 is 1. I can now rewrite it as a neat little integral. Because I have u to the power of 7 du. Add 1 to the power over the power, substitute in, and we get our answer. There it is, 1/8. Just finish up with this one from, well, it's a few years ago now, 2020 paper, and we got this expression. And the angles are different. So one's 5x, one's 3x. So this is where we're going to use our product to sums idea. And again, if you forget it, it is on the reference sheet, so you could always use it. Look it up there if you didn't remember what it is. But basically, it's sine the sum, sine the diff. Let's add them together, we get 8x. Subtract them, we get, well, hang on, I've got negative 2x, not 2x. And the reason is, see how that says cos sine? That formula was when it's sine cos. So actually it's the other way around, and you'd go 3x minus 5x. So we get negative 2x. Sine of negative 2x, well, I'm now taking advantage of the fact that sine is an odd function. So sine is an odd function, and we get minus sine 2x. We can now integrate. The sine will go to minus cos. So I get minus 1/8 cos 8x plus a half cos 2x. Substitute in our limits, and we end up with our answer of minus a half. So D and E, that'll do us for today.